To produce a shipment of transistors containing 100 units requires 1 hour of engineering. So availability they have given this 2000 for machine M1, 5000 for machine M2 and subject to constraints. So we have 3 different wool called red, green and blue. Hello everyone, welcome back to my new session. I am Shweta, Computer Science Faculty, Vidhyaashram First Grade College, MYSURU. In my last session, I have discussed about the formulation of LPP. I have discussed some problems on LPP model. So today, I will continue that problems. First problem, consider a company manufacturing chocolate that produces only 2 types of chocolate. I will consider that is A and B. Company manufacturing 2 types of chocolates, that is chocolate A and chocolate B. Both the chocolates require milk and choco only. So raw materials is milk and choco. A company is manufacturing chocolate that produces only 2 types of chocolate, that is chocolate A and B, and for that both the chocolate require milk and choco. This is a raw material for producing a chocolate A and chocolate B. To manufacture each unit of A and B, that following quantities are required. So here we have some given data. Each unit of A requires 1 unit of milk and 3 units of choco. Listen carefully. Each unit of A requires 1 unit of milk and 3 unit of choco. This is a given data. Each unit of B requires 1 unit of milk and 2 units of choco. So, first write the table. A company's kitchen has a total of 5 units of milk and 12 units of choco. 5 units of milk and 12 units of choco. That means the company kitchen has a total of 5 units. That means it is a availability of this product. Company kitchen has a 5 unit of milk and 12 unit of choco. This is availability, and on each sale, the company makes a profit of 6 rupees per unit A. So, profit of 6 rupees and 5 rupees per unit B. So, rupees 5 and rupees 6 for unit A and rupees 5 for unit B. So, they have given the profit value. And now the company wishes to maximize its profit. Obviously, company is manufacturing a product means they are expecting the maximization. They are expecting the maximum profit, right? So, here we have some given data. Using this data, we can construct ALP model. So, first write the table. Using this data, we can construct a table, and after that easily you can construct LP model. So, first step is decision variable. So, I will consider this is x1 and x2, x1 and x2. So, for chocolate A, I will consider a decision variable as x1, and for chocolate B, I will take it is x2. So, decision variables. Then what is the objective function? Profit of this product is 6x1 plus 5x2. So, objective function is equal to 6x1 plus 5x2. This is my objective function. And constraints. So, for product A and product B, we have some given data, that is constraints x1 plus x2. So, availability is less than or equal to 5, and the second constraint is 3x1 plus 2x2 less than or equal to 12. So, this is my constraints value. So, first write the objective function, it is 6x1 plus 5x2, and the constraint value is x1 plus x2 less than or equal to 5 and 3x1 plus 3x2 less than or equal to 12. And the non-negativity constraints, so x1 is greater than or equal to 0, x2 greater than or equal to 0. So after this you can construct LP model. So LP model is, so Z max or max Z, this is maximization problem. So max Z is equal to 6x1 plus 5x2 and subject to constraints x1 plus x2 less than or equal to 5, 3x1 plus 2x2 less than or equal to 12. Why it is less than or equal to 5 and less than or equal to 12? As availability, I have considered as a less than or equal to 5 and less than or equal to 12. So this question is maximization problem. If it is maximization problem, you need to use less than or equal to with the constraints, and if it is minimization problem, need to use greater than or equal to constraints. How can you find out this maximization or minimization problem? So if you find any keywords called manufacturing, produces, creates, so it is maximization problem. So this is your LP model, and finally non-negativity constraints where x1 is and y1 is greater than or equal to 0. So this is your LP model. Very simple concept. Please read the question properly and directly you can prepare a LP model. So first try to write this table and prepare a LP model. So next question is, an electronic firm is undecided at the most profitable mix. So it is maximization problem. For its products, the products manufactured are, so we have some products, transistors, resistors and carbon tubes. Transistors and resistors, carbon tubes. With a profit of per 100 units, that is, we have the profit values and it is produced by, and this product is produced by engineering, direct labor and administrative. Engineering and direct labor and administrative. So now you can write the given values. So here we have 3 products, transistors, resistors and carbon. So here they have given the profit value. So 10 rupees, 6 rupees and 4 rupees respectively. 10 rupees, 6 rupees, 4 rupees respectively. And to produce a shipment of transistors containing 100 units requires 1 hour of engineering. This is for transistor. Transistors containing 100 units requires 1 hour of engineering and 10 hours of direct labor and 2 hours of administrative service. To produce 100 units of resistors requires 1 hour of 4 hours and 2 hours of engineering, direct labor and administrative. So 1 hour, 4 hour, 2 hour for engineering, direct labor and administrative. So for 100 units of carbon tubes, it needs 1 hour of engineering and 6 hours of direct labor and 5 hours of administrative. So this is our given value, and also we have, there are 100 hours of engineering time, 600 hours of direct labor and 300 hours of administrative time available. So here we have time availability also. So time available. So time availability is 100 hours for engineering and 600 hours for direct labor and 300 hours for administrative. So first write all the given values, then easily you can construct LP model. So this is maximization problem. So here I will take the decision variable as x, y, z, x, y, z and x, y, z. So first write the decision variables. I will write x, y and z. So objective function is max z is equal to 10x plus 6y plus 4z. So this is your objective function, and constraints are, so 1x plus 10y plus 2z. So here we know the availability for engineering, direct labor and admin. So you have to consider like this: 1x plus 1y plus 1z less than or equal to 100. 1x plus y plus z less than or equal to, availability is 100. Time availability is 100 for engineering, and 10x plus 4y plus 6z less than or equal to 600 for direct labor, and 2x plus 2y plus 5z less than or equal to 300 for administrative. So this is our constraints value. So we got the profit value, objective function is equal to 10x plus 6y plus 4z, and we got the constraint. So non-negativity constraint is x, y, z greater than or equal to 0. So this is your LP model. So my dear students, this is very simple concept. The question is very big, but the answer is very small. So easily you can construct LP model using the real-time situations. And the next problem is, here we have the table. So easily we can construct the LP model. A company manufactures 3 products, P1, P2 and P3. The profits are 30. So they have given the profits value. Profits are 30, 20 and 40. A company manufactures 3 products, P1, P2, P3, and we have 2 machines, M1 and M2. Here they have given the total time availability for 2 machines called M1 and M2. And the profits are 30, 20 and 40. They have given the profit values. So I will write the profit first. So profit is 30, 20 and 40 for product 1, product 2 and product 3. And a company has 2 machines called M1 and M2. Processing time in minutes for each machine on each product on the total time availability on each machine are given in the following table. So using this table, we can construct LP model. So first I will write the decision variable. So I will take x, y, z, x, y, z. So decision variable x, y and z. So what is the objective function? Objective function max z is equal to 30x plus 20y plus 40z. So this is the objective function, and subject to constraint 2x plus 3y plus 5z. So availability is 2000, so less than or equal to 2000, and for machine M2 4x plus 2y plus 7z less than or equal to 5000. So this is our subject to constraints. So availability they have given this 2000 for machine M1, 5000 for machine M2. So this is a constraints value, and finally non-negativity constraint. So x greater than or equal to 0, y greater than or equal to 0, z greater than or equal to 0. So this is my LP model. So using the table easily you can construct LP model. And the next problem, a firm can produce 3 types of cloth, say A, B, C. 3 kinds of wool are required for it. So here we have 3 kinds of wool, A, B, C, and so the wool colors are red, green and blue. Red, green and blue. 1 unit of length of type A cloth needs 2 meters of red wool. 2 meters of red wool and 3 meters of blue wool. 1 unit length of type B cloth needs 3 meters of red wool and 2 meters of green wool and 2 meters of blue wool. And 1 unit of type C required cloth needs 5 meters of green and 4 meters of blue wool. So this is 0 and this is also 0. The firm has only a stock of 8 meters of red wool. So they have given the stocks for each color's wool. So firm has only stock of 8 meters of red wool, 10 meters of green wool and 15 meters of blue wool. It is assumed that the income obtained from 1 unit length of type A cloth is, they have given the income for each type cloth. Type A cloth is of, so income per unit for A cloth it is rupees 3 and for type B cloth rupees 5 and type C cloth is rupees 4. So this is a income per unit. Determine how the firm should use the available material so as to maximize the income. So this is your given data. So using this data, you can construct the LP model. So first write the decision variable. I will consider x1, x2 and x3. x1, x2, x3, x1, x2, x3. So what is the objective function? Objective function max z. This problem is maximization problem. So I will use max z is equal to, so what is the profit? 3x1 plus 5x2 plus 4x3. So this is my objective function. And subject to constraints. So we have 3 different wool called red, green and blue. So first constraint is 2x1 plus 3x2. So for type C there is no value. So I will write it is 0. Less than or equal to stock value is 8. And for type A there is no value, then I will write 2x2 plus 5x3 less than or equal to 10 and 3x1 plus 2x2 plus 4x3 less than or equal to 15. So these are the constraints. And non-negativity constraints where x1, x2 and x3 greater than or equal to 0. So this is your LP model. So first write the objective function, subject to constraints and non-negativity constraints. And the last problem is, the manager of deep sea oil refinery must decide on the optimal mix of 2 possible blending process of which the inputs and outputs per production run are given in the following table. Formulate the problem as a LPP. So here we have one table. So processing is for A and B type and they have given the total availability. So for input per units, they have given output per units for crude and gasoline, and we got the profit value also. So to seeing this easily, we can construct the LP model. So first write the profit, that means maximization value. So first I will consider the decision variable x1, x2, x1, x2, x1, x2, x1, x2. So decision variable x1 and x2. So objective function. So what is the objective function? So max Z is equal to profit is 400 x1 plus 500 x2. So this is your objective function. So max Z is equal to 400 x1 plus 500 x2 and subject to constraints. So subject to constraint. So for crude process 6x1 plus 4x2 less than or equal to availability is 300. And for second crude Q 2x1 plus 3x2 less than or equal to 250. And for gasoline 5x1 plus 7x2 less than or equal to 120. And for T 7x1 6x2 less than or equal to 100. So this is your constraints values. And finally non-negativity constraints are x1 and x2 greater than or equal to 0. So first objective function, subject to constraint and non-negativity constraints. So where x1 and x2 greater than or equal to 0. This is your non-negativity restriction. So this is called as LPP model. So using mathematical model, we can construct linear programming. It is very simple model. By seeing the question only, you can construct LP model. In my next session, I will discuss some more problems on LPP. Thank you.